Okay, problem number 7 of worksheet 4 is a pretty challenging problem. So I'm going to go ahead and draw in the forces that act on this. There's going to be a weight force that acts right from the center of mass. There's going to be a tension force this way. There's going to be a tension force this way. Let me label these. This is force of tension 1. I'll call this one here force of tension 2. And I'll call this one the weight. The only one of these that I know is the weight, which is 500 newtons. Now you might be tempted to put the pivot point at one of the two unknowns. The problem is we don't know the distance from the application of one force to the other side, and so you can't assume that's right along the diameter. This might be down a little bit further, this might be up a little bit further. So I'm going to pick the pivot point to be right in the middle. So from this, my torque equation becomes torque from 2 equals torque from 1. Torque from 2 would be Ft2 times the distance away, which would be 0.375 meters, times, it says that it's tangentially to the outer edge, so that means it's going to be 90 degrees then. I mean, that if it's tangent to the circle, then that means it's 90 degrees from the radius. Okay, so I don't have to worry about that. So that's going to be equal to then Ft1 times the distance away, which would be 0.09 meters. And so I find that Ft2 equals 0.24 times Ft1. Okay, so I have one equation, two unknowns there. So that's not really going to be very helpful at this point. So let's see if I can figure out some other equation. I could say that Ft2 in the x direction must be equal to Ft1 in the x direction. So that would be Ft2 times the sine of theta equals Ft1 times the sine of 10 degrees. And now I have three unknowns and I only have two equations. So let's see if I can come up with another equation. Looking at the vertical direction, I could say that Ft2y plus Ft1y must be equal to the weight. So this would be Ft2 times the cosine of theta plus Ft1 times the cosine of 10 degrees must be equal to 500 newtons. Okay, well, I think what I'm going to do is I'm going to plug in that first equation into this and see what I get. So let's see here. So I would have 0.24 times Ft1 times cosine of theta plus Ft1 times the cosine of 10 equals 500 newtons. Let's see. For the second equation, I think I'm going to go ahead and plug in this as well. this would be 0.24 times ft1 times the sine of theta equals ft1 times the sine of 10. I can cancel both sides by I can divide both sides by ft1, and I get that sine of theta must be equal to sine of 10 divided by 0.24. So that means that theta would be equal to 46.3 degrees. Okay, that's good. So if I know the angle, then maybe I can plug that in over here. So let's see if I can try that. So now I have 0.24 times ft1 times cosine of 46.3 degrees plus ft1 times the cosine of 10 degrees equals 500 newtons. So that means ft1, because I can factor it out, must be equal to, let's see, 500 434.5 newtons. Okay, so as soon as I know ft1, then I can plug it back in over here, and I can figure out what ft2 is. ft2 must be equal to 0.24 times 434.5 newtons. That means ft2 must be equal to 104 newtons.